two questions. The units you've got on these two aren't plugged in. Is that just because they're for demonstration, or there's a wireless connection?
No, that is just a demo. So when we mount this, we do actually put a cable down to the battery so then they stay plugged in. But it can be mounted at any height, so we can move it down closer to the battery there.
Okay, so it requires a professional installation?
It requires not somebody with too many skills, because we are developing all of the different plugs that go into all the different battery types, and that's the only bit of the system that changes. So it's literally the end of the cable, different plugs to go into different batteries. This unit is smart enough that it knows what sort of battery it's plugged into, so nothing else needs to change. It's literally just the plug going into the battery.
Okay, and is the tracking accurate enough to know what the rider is doing? Because one of the big problems, for instance, with the shared fleets is the riders don't obey the road rules, they obliterate all sorts of things. The fleet should be policing that in this system, provide that kind of accuracy.
Look, it's a really good question, Jordan. I'd have to go back to the specs of the IoT module that we're embedding in it, because that's what does the DPS tracking. Do you recall, Dave, what the accuracy of that was? Do you remember?
GPS
Yeah.
is very high.
Do you know?
So
roughly what?
similar to smart.
Similar to smartphone. So what, within a couple of metres?
A couple of meters.
A couple of metres, yeah. Whether that's quite enough in some circumstances to tell that somebody's riding on a footpath, for example, versus riding on a bike lane, probably not. But one of the things we could do in the future is actually embed more smarts in this box that could speak to on-street sensors, and that would give you much more accuracy. So that sort of capability we could build into it.
Just on that, Al, I think there are others out there that really specialise in very detailed stuff, that where this could become a box where third-party things could API into it, so this becomes the container for a whole range of micromobility IoT tracking sensors for different purposes.
That's right, Stephen. Yeah, Stephen's from Zippity, and they really good on this stuff. They work all over the world on different micromobility projects. And yeah, so Stephen's right. That's very much how we view this. This box is just a platform, and we're really happy to partner with other tech providers to embed their technology into it. So in the future, I could see cameras, I could see LiDAR, you could see a whole bunch of things going into that. Yeah, so that's very much the plan. That might be a third, fourth, generation system, but it's certainly on the roadmap. Daniel?
Are you considering an inbuilt model? Obviously, with Cargo Craft and ELV, you've got your own bikes and things. Are you looking at an inbuilt model where this comes as a native?
Yeah, look, possibly the ultimate goal of this would be to shrink that device down to the point where we can give the specs to bike manufacturers and it gets built into the frame of the bike at the point of manufacture. So rather than being something you add later, that just sort of becomes like an integral device that's part of the build of the bike. That would be the ultimate goal. And look, for that reason, we, luckily we do have we do talk to Bosch, Shimano, some of the industry leaders, because we've been working in this space for a long time. So we do have connections in the industry. So that would certainly be our goal, would be to make it, like an integrated device, like an OEM device. Yeah.
Can batteries still be plugged into their regular charger when they're plugged into that as well?
Yeah, so one of the things we're looking at is whether we have a piggyback plug. So what I mean by that is the device, the one key device is plugged in, but on the back of the plug is the same socket, so that you can charge it using your ordinary battery charger at home if you wanted to. Our hope is that OneDock will become so common that they'll be on every street corner, so you wouldn't need to bother with that, because you can plug it in anywhere. It'd be sort of like bike hoops, but smart bike hoops. Yeah, that would be the ultimate goal. Yeah.
Does one key detect what kind of battery is on the vehicle, or does it? Do you need to program it?
We're actually looking at both options at the moment. We can certainly program it because we have a microprocessor that sits in there, and we can program the battery type into it. But some of the batteries we can detect automatically, because the module the smart IoT module that we're getting from TrackApp, they're partnered with some of the big battery manufacturers, so COO Al Reid.
Well, the reason I ask is I imagine a lot of people wouldn't know what kind of battery is in their device.
No, but they don't
And would be
yeah.
able to program it, and a device might not pick up what kind of battery is in it. So
Okay.
how do you kind of tune it to that?
It's a very good point. So at the moment, this device, we aren't just giving to the end consumer. The idea would be that this would be with our technicians, but also potentially with bike shops. And we train the bike shops in how to fit it and how to program it so that it has the right battery programmed into it. Yeah. And once it's on, you can't take it off unless you've got the right tools to take it off. So it's sort of married with that battery once it's been programmed in.
Will it detect unsafe batteries?
Yeah, so what happens, okay, will it detect unsafe batteries? So because we and our team and bike shops, for example, are the ones who control the fitting of this device, if they come across a device that doesn't have a battery that meets the Australian standards, they won't fit the device. So this gives you a point at which you can check for the for the compliance of the vehicle or the compliance of the battery. And this is the big problem at the moment is there's a whole lot of, particularly from China, and you'll see them running around, mostly used by food couriers, batteries that just don't meet the standards, and they're the ones that catch on fire. So we would not connect our device to one of those batteries. We would check the battery and make sure that it was actually compliant. So that's the first thing. The second thing is that if someone did somehow manage to swap this device onto a different battery, it would actually be expecting a certain type of battery, like a Shimano 48-volt battery. It switches to that charging program, and then it gets a different, a different response from the battery, and it'll just switch itself off. So that's actually built into the capability of the charger that sits inside the dock.
Al, just looking at it, I assume most of the smarts are just all on the top, and the tower there, most of it is just unused space.
Yeah, yes, that's true, Cam. So one thing I probably should have pointed out is that the smarts, as you've said, are actually very compact inside here, so it doesn't have to be mounted on a post. This is completely modular, so you could take it to a smart post. You know the street lamps you see these days that have all sorts of tech, built into them. We can create a little collar that has the two programmable chargers and the charging socket mounted on it, and you just mount that onto a street light. Power's already in the street light, so you've got a power source, and so that would be another way.
So you can optimise the space allocation for bike position.
Absolutely, yeah. So this is not set, so we can change the spacing between the docks. So this particular spacing means you can fit 5 docks and 10 bikes inside a shipping container, and that's one of the versions that we're looking at. Is a 20-foot shipping container, potentially solar powered, so it can operate off grid, and all of the docks just line up against the back wall, and you can fit 10 bikes. Yeah, but you can change the spacing because it's completely modular.
Hi, Al. What sort of price point do you sort of envisage the device being at?
Sure. So the price point at first is obviously going to be more expensive because we have smaller scale production. But at the moment, we're roughly looking at $3,000 for the dock, which will charge 2 vehicles, and $400 to $500 for this device. But we expect those prices to come down a lot as we scale production. But that's our sort of initial price target. And if you consider all the other benefits, the cost savings, for example, if you've got a car fleet and you're switching somebody to car fleet for this, even though you've got to invest a bit up front, the savings that you'll make on the operation of the thing will very quickly pay off.
Sorry, another one.
Yeah.
Is there revenue grade electricity metering in the OneDock, or is the electricity cost so small that you wouldn't bother?
The second.
Yeah.
So just to give you an idea, one 10 amp power point will charge 10 e-bikes simultaneously. Right? Compare that to an EV, to a Tesla, for example, where you need to install sometimes a substation inside an office building because they're drawing so much power. this plugged into the wall, like we've done here, and it'll charge 10 vehicles. And that's just on a 10 amp circuit. So on a 30 amp circuit, basically it's 1 amp per vehicle. So 30 amp circuit, 30 vehicles. So it's completely different, and you just wouldn't bother, you know, adding up the electricity. To give you an idea, 15 cents charging cost on a scooter, 25 cents on an e-bike at today's prices. And that will give you a range on this one, it's about 50 k's, and that one's about 100 k's. So the cost per kilometre is incredibly cheap. Good question, I think.
How long will it take each of those bicycles to get charged for?
Yeah, so one of the interesting features, how long would it take to charge them? So the smart charger inside actually has a fast charging mode. The issue is that most battery management systems that come on the battery pack don't actually allow the power output that thing can do. So in some ways we've sort of made it a bit future-proof. That charge can pump out 8 amps. Most battery chargers are about 2 amps. The really, like the fastest one I've seen on the market is 6. So to answer your question, it will take about 5 to 6 hours to fully charge this one. Yeah, similar time. So it's not like charging an EV. So it's not like you going up the Hume to Sydney and you stop by, get a fast charge and go on your way. This is much more about sort of urban transport. And you know, you can leave your vehicle in a dock and it just charges every time you dock it. So it's always getting topped up. It can even do things like you can program it so that it does an 80% charge, because lithium batteries last a lot longer if you only charge them to 80%. So you can program that in, and as the user you can select, I want every time I dock my vehicle that it only charges to 80%. So that charge can do that. How are we doing for time? I'm wondering. Are we good? Or?
Yeah, well, 11:22, so...
Okay, well, if people are happy to just hang for another couple of minutes, yeah. John?
So following up on that, there's two elements here. There's the data. So how much of the data is retained inside the device, and then how much do you get to keep for building a profile of how your systems are working all over the world? And talking about the app, can I use the app to interact with the device without being near a station?
Yes. So, for example, if you're parked at a cafe and rather than using a dock, you just use your own chain and plug it into the device, you get out your app and that's how you unlock it. So, and you can be anywhere to do that. So, it works off 4G, I think. The IoT, maybe it's at 5G, I'm not sure. No, I'd have to look at that. So in terms of data gathering ability?
Sorry, just to interrupt. So if it's saying it works off the cell phone system, so I'm actually dialing to this device, I don't have to type a number, I understand, but I'm dialing to this device through the network or direct?
There's two options, it can do both. So we can actually give users Bluetooth tags as well, and they can literally tap it on the device and that'll unlock it. Or they do it through the cellular network. Possibly Wi-Fi too. Sorry, I should have come better prepared.
That's okay. The data question.
Yeah, and so data. Yeah, so with the data, basically you're beaming up to a satellite via the IoT module. So you will. I'm not sure of the frequency of the data gathering. I think it might be every few seconds, something like that. In terms of can we keep the data? Absolutely. Can we see who the user is? That depends on the privacy settings. So if it's a private vehicle, people can choose to mask their ID because they don't necessarily want us to know who they are. But you can certainly do the aggregated data. So if you've got a fleet, you can see all the vehicles, and as the owner of the fleet, potentially you can see the users, but again, that depends on the privacy settings. But you can set all of those things in the fleet management software as to the level of sort of visibility. Great questions, thank you.